When dealing with grounding water lines in relation to electrical systems, there are important distinctions to make between branch circuits and the service entrance. For a branch circuit, an 8 AWG copper wire is typically recommended for grounding purposes. However, for the service entrance, the appropriate wire size is dependent on several factors, namely the total amperage draw of the electrical system and the distance to the utility transformer. As a general guideline, a 100 amp service often requires 2 AWG or 3 AWG copper wire, while a 200 amp service usually necessitates 1/0 AWG or 2/0 AWG copper wire. It is crucial to understand that water line should never be directly grounded to the electrical system. Direct grounding to a water line can create a potentially hazardous situation, increasing the risk of electrical shock or damage to plumbing components. To ensure safety and compliance with electrical codes, a licensed electrician should be consulted to properly ground the water line and assess the overall electrical system. The electrician will evaluate the specific conditions of the installation, including the type of water pipe, the presence of any dielectric unions, and the proximity to other grounded elements. Proper grounding helps to minimize the risk of electrical faults, protects against stray currents, and ensures the safe operation of electrical appliances and equipment. When considering grounding, one must differentiate between system grounding and equipment grounding. System grounding refers to the intentional connection of a neutral conductor or a grounding electrode conductor to earth, establishing a reference point for the electrical system's voltage. Equipment grounding, on the other hand, involves connecting non-current carrying metal parts of electrical equipment to ground, providing a path for fault currents to flow back to the source, thereby tripping a circuit breaker or fuse and energizing the circuit. The National Electrical Code, or NEC, provides comprehensive guidelines and requirements for grounding and bonding electrical systems, which must be followed to ensure safety and compliance. The NEC specifies the minimum size of grounding conductors based on the size of the overcurrent protection device protecting the circuit. For example, NEC Table 250.122 provides guidance on equipment grounding conductor sizing for various circuit ratings. It is important to note that the size of the grounding conductor is not always the same as the size of the circuit conductors. In some cases, the grounding conductor may be smaller than the circuit conductors, but it must still be sized appropriately to safely carry fault currents. Bonding is another critical aspect of electrical safety, which involves connecting all non-current carrying metal parts of an electrical system together to create an electrically conductive path. Bonding helps to equalize voltage potentials and minimize the risk of electrical shock. The NEC requires bonding of various metal components, including metal water pipes, gas pipes, and metal building structures. Bonding is typically achieved using bonding jumpers, which are conductors used to connect different metal parts together. The size of the bonding jumpers is also specified in the NEC, based on the size of the circuit conductors. When grounding a water line, it is essential to ensure that the grounding electrode conductor is properly connected to the water pipe. The grounding electrode conductor should be connected to the water pipe within 5 feet of the point where the water pipe enters the building. The connection should be made using a listed grounding clamp or fitting. If the water pipe is interrupted by a dielectric union or other non-conductive fitting, a bonding jumper must be installed to maintain electrical continuity. In addition to grounding the water pipe, it is also important to ground other metal components of the plumbing system, such as metal faucets and shower heads. These components can become energized if there is a fault in the electrical system, and grounding them helps to protect against electrical shock. The NEC also addresses the grounding of electrical equipment in wet or damp locations, such as bathrooms and kitchens. In these locations, ground fault circuit interrupters, or GFCIs, are required to protect against electrical shock. GFCIs are designed to detect even small amounts of current leakage and trip the circuit, preventing a potentially fatal shock. When working with electrical systems, it is crucial to follow all safety precautions and wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Electrical work should only be performed by qualified and licensed electricians who have the knowledge and experience to safely install and maintain electrical systems. Improper grounding can have serious consequences, including electrical shock, fire, and equipment damage. It is therefore essential to take grounding seriously and follow all applicable codes and standards. In summary, determining the appropriate wire size for grounding water lines depends on whether it's a branch circuit or a service entrance. Branch circuits typically use 8 AWG copper wire. Service entrances require larger wire sizes, such as 2 AWG or 3 AWG for 100 amp services, and 1/0 AWG or 2/0 AWG for 200 amp services, dependent on total amperage draw and distance to the utility transformer. Direct grounding of water lines to the electrical system is dangerous and should be avoided. Consulting a licensed electrician is always recommended to ensure proper grounding and electrical safety. Firstly, understand the difference between system grounding and equipment grounding. Secondly, adhere to the National Electrical Code for grounding and bonding requirements. Thirdly, ensure proper connection of the grounding electrode conductor to the water pipe. Fourthly, bond all metal components of the plumbing system. Fifthly, use ground fault circuit interrupters in wet or damp locations. Sixthly, always follow safety precautions and wear appropriate personal protective equipment. Seventhly, only allow qualified and licensed electricians to perform electrical work. Eighthly, be aware of the consequences of improper grounding. Ninthly, take grounding seriously and adhere to all applicable codes and standards. Finally, if you are unsure about any aspect of grounding, consult a licensed electrician.